AI is starting to move past generate one answer and into systems that can edit, restore, and ground content with much less supervision. What's striking is that these models are now learning from bootstrap predictions, foundation model generated targets, and multi-instance video supervision instead of expensive paired datasets. That means better editing with no image pairs, restoration trained on synthetic ground truth that people actually prefer, and video understanding that can find every matching moment, not just the first one. The real story is how far weak supervision has gone and where it still breaks. Let's explore the first paper, Bootstrap Your Generator, Unpaired Visual Editing with Flow Matching. Bootstrap Your Generator, from NVIDIA and Tel Aviv University authors, Yoad Tuel, Yuval Atzmon, Gal Chechik, and Lior Wolf, proposes an unpaired training framework for flow matching visual editing that needs no source, target image pairs, and no external reward model. The key idea is to fine-tune a pre-trained text-to-image or text-to-video generator using only source captions, target captions, and inverse instructions. A frozen EMA copy of the model first, bootstraps pseudo-targets by multi-step sampling, then the trainable editor is supervised by a semantic prior that aligns the edit direction between source and target prompts, plus a cycle consistency loss that reconstructs the source after applying the inverse edit. To make cycle training work on flow matching models, the paper introduces gradient routing with straight-through estimation, so clean multi-step predictions condition the reverse pass while gradients flow through the noisy one-step state. Experiments on WAN 2, video editing, and Flux, dev image editing, show strong gains on long-tail, data-scarce edits. In a user study, the method wins 75.3% of comparisons against Ditto, a supervised baseline trained on 1 million video pairs, and it generalizes to unseen 3D CGI videos with an 85% win rate. On gedit bench, it matches or exceeds Flux context and flow edit across categories, especially motion, human, and style edits, while ablations confirm that bootstrapping, directional regularization, cycle loss, and gradient routing are all necessary for preserving structure without collapsing to identity. Let's explore the second paper, GGT 100K Generative Ground Truth for Generalizable Real-World Image Restoration. GGT 100K proposes a new data paradigm for real-world image restoration by using multimodal foundation models, rather than physical capture or synthetic degradations, to generate generative ground truth targets from low-quality images. The authors, from the Hong Kong Polytechnic University and Oppo Research Institute, systematically benchmarked 9 MFMs, including OpenAI's GPT Image 1.5 and GPT Image 2, Google's Gemini-based prompting, Black Forest Labs' Flux 2dev, and Nano Banana 2 across fidelity, perceptual quality, VLM-based acceptance, and human preference. Nano Banana 2 with Gemini-based adaptive prompting was selected as the best balance, achieving the top overall score of 0.84 and the highest human preference at 32.5%. Using this model, they built GGT 100K with 103,707 training pairs at 1024 times 1024 resolution and a 500 pair test set, spanning general mixed corruption, rain, haze, snow, low light, and old photos. A 3-stage quality control pipeline, no reference metric filtering, VLM-assisted refinement with Gemini 3, 1, Pro, and manual verification removed hallucinations and structural inconsistencies. Training on GGT 100K consistently improved generalization across CNN, Transformer, all-in-one, and generative restoration models. For example, NAFNet gained 3.12 decibels PSNR and plus 26.2 percentage points VLMR, while XRestormer improved by 3.54 decibels and plus 24.2 points. The largest benefits appeared in generative models such as Flux ControlNet and Qwen Image Edit, showing that foundation model-generated supervision can expand restoration beyond the limits of existing paired datasets. Let's explore the third paper, Towards One-to-Many Temporal Grounding. Towards One-to-Many Temporal Grounding, from a team including authors at Wuhan University, Peking University, Nanyang Technological University, and the National University of Singapore, formalizes a new video understanding problem where one text query must retrieve all disjoint matching moments in a video rather than a single segment. The paper argues that existing MLLMs such as Gemini 2.5 Pro, Gemini 3 Pro, Seed 1, 8, and Qwen 3 VL fail because they lack event cardinality perception, often merging multiple occurrences into one span or hallucinating extra segments. To measure this setting correctly, the authors introduced the OMTG bench, a 340 sample benchmark with manually verified multi-segment annotations, plus new metrics, count accuracy, temporal F1, and effective temporal F1, which zeroes out examples with wrong segment counts. They also build a 5.6K sample instruction tuning dataset using a 5-stage pipeline based on Qwen 3VL235B and Gemini 2.5 Pro, including repetitive event discovery, grounding, strict visual veto filtering, recall checking, query refinement, and query-guided dense captioning. Training combines supervised fine-tuning with GRPO reinforcement learning using a composite reward that explicitly optimizes temporal IOU, count accuracy, caption quality, and output length. On OMTG Bench, their OMTG-4B model reaches 43.65 ETF1, outperforming Gemini 2.5 Pro by 15.85 points and Seed 1, 8 by 15.61 points, while also improving standard one-to-one grounding on timelens and general video understanding on video MME. That's a wrap on today's AI paper highlights. Thanks for watching.